Great. Well, we have reached the 50 participant mark, so we will begin. Welcome to this webinar on bridging the gap with the PyPSA task force. Fabian, would you go one slide, please? PyPSA, or Power System, Python for Power System Analysis, is an energy system modeling tool that began its life in 2015 when it was first released by Tom Brown, now professor at TU Berlin in Digital Transformation and Energy Systems. And I had the privilege to meet Tom and his team back in 2017 for the first time as a developer of a completely different tool, and watched from a different domain as this community that is PyPSA grew and grew exponentially practically over the years, starting off as a pure power system analysis tool, growing to cover all sectors, to introduce more and more complex and advanced features in its arsenal, and growing an ecosystem around it that did more than just energy system modeling, but did elements of data preparation and model building as well with its products like PyPSA Earth, PyPSA Europe, AppLight, and LinnerPy, etc. So it's my privilege to be able to moderate this session. I'm Bryn Pickering. I'm a senior energy system modeler at the Open Energy Transition, and to be joined by some fantastic people to discuss some of the more recent developments in PyPSA and where we're looking to go in the near future with dedicated development efforts to close the gap with proprietary tools. So I'm joined today by Fabian Hofmann, Senior Optimization Energy System Modeling Expert, Patrick Freitag, Expert for Energy System Modeling at the German transmission system operator Amprion, and Iegor Riepin, who is a postdoctoral researcher at the Department of Digital Transformation in Energy Systems at TU Berlin. We're going to start in a couple of minutes with Fabian giving you an introduction to what is the PyPSA Taskforce, and then we'll move into a panel discussion with a live Q&A for the remainder of the session, so that you have the opportunity to ask your questions to us about where PyPSA is going and when you can start using it, and the answer is already, for all of your modeling needs in the energy system domain. A couple of housekeeping rules before we start. I'd ask that you stay muted and that you turn off your camera, except for the panelists. There will be a recording of this afterwards, so this entire session is being recorded and it is being transcribed. And it will be made publicly available afterwards. Please don't use the chat function on Zoom, but instead follow the QR code or go to slido.com and use the numbers that you can see on the screen here, 9244277, and pose your questions there, and we will draw the questions for the Q&A directly from that Slido session. So without further ado, I'd like to hand over to Fabian to give us an introduction to PyPSA Taskforce.
Thank you very much, Bryn. So today, I'm quickly talking you through the PyPSA Taskforce, the initiative that we launched with its goals and strategies. So, as Bryn already mentioned, the PyPSA ecosystem has grown significantly over the last years. And nowadays, you could say it's a trusted package with follow state-of-the-art open source maintenance standards. And it's widely adopted. You'd see it in multiple research teams. And so to go through these blocks, we have state-of-the-art open source maintenance on the projects. We have a quick release cycle, extensive documentation, modular architecture of the software, and high test coverage. And all of this is open source. You can see it on GitHub. We have the code there. You see all the issues. We have pull requests, all available to the wide community. There's already over 60 different organizations using PyPSA, from academia, industry, regulators, NGOs, and people who just enjoy energy system modeling. And this growth that we saw over the last years also reflects in stars on GitHub. We have over 2,000 stars now, which gives a significant sign that PyPSA is going into the right direction. Yet there is a problem when it comes to the wide application of the tool. We see that in particular it's still concern across the industry partners, and they would rather accept cost to closed source tools, and that they can neither inspect nor direct. And these costs are one point financially, so you have to pay for licenses, sometimes very high licenses. There's an opaque code that you run, essentially. You don't have insights into what you actually processing in terms of data, how the model in its core is running. And that also goes for the data model. So if you can compare it to PyPSA, you already see what is in your data model, how data is processed in the back end of your model. And of course, you have less control over these proprietary tools. Roadmaps are sort of decided on in a closed room, and you can't shape them from the outside. There is a community, of course, and you can sort of drive some demands, but in its sense, you are not part of the roadmap. And what we believe is that we can cover all these needs and get rid of the deficits by making PyPSA widely more applicable. And our vision is that PyPSA becomes the clear choice of, in the moment it covers all the different capabilities that proprietary tools provide today in a secure and stable environment. And when I talk about we, it's a collection of different institutes. It's the Technische Universität of Berlin, who's also joining today, University of Pisa, and Open Energy Transition. So how did we come to this point? So after we had thought through the situation, we see there is this nice tool, and we would like to have industry partners more on board and applying the tool because we think we are almost there. We sat down last December together, and we had a round of us and trying to identify the technical areas where PyPSA is still lacking in terms of what areas need to improve to really fill the full, complete set that proprietary tools provide today, and even beyond, because there is already a set of functionality that PyPSA ships that proprietary tools don't. And we can group these areas into 5 upper groups, meta groups. One of it is the operational realism. There is still some things in PyPSA that you can't do today to a certain detail. For example, when you do operational dispatch of unit commitment, there's things like maintenance and outages and startup trajectories. There's hydro storage and physics and piecewise efficiencies and costs and capacity expansion with UC. And you already see that some of these points that are here now in the left column are already marked in green or in yellowish. Green means we have already tackled them since the beginning of the initiative, and yellow is it's very close to be shipped, expected to be coming in the next PyPSA version. The second category that we would see is investment and expansion. There is still some things that we don't cover in PyPSA in terms of when to retire certain assets and reinvesting into assets. Flexible future demand, so having a operational reactive or active demand consumer that is participating in the market, endogenous learning, and a fixed operational and maintenance cost and capex split, which is already covered as well here. So this group is rather going to the direction of how to do the long-term planning with PyPSA in a more detailed fashion. A lot of these features that you see here, they can be modeled to some certain extent with user code, but we want to provide that through the package and really make it easy to users to leverage the full functionality without worrying too much about certain constraints that the user might want to find. Reliability and uncertainty is the next big block. Expected energy not served, loss of load, probability, reserve margins, all these things that you do apply when you have certain set of scenarios that you want to analyze. Multi-stage stochastic and Monte Carlo optimization also go into this direction. Market mechanisms, when it comes to contracts and PPAs and penalties, more like this policy-driven techniques, mechanisms, we want to provide a toolbox that can also reflect this. It also comes with reserves and strategic behavior, market behavior, where certain assets play their power and shape the market to their benefits. And the last point would be performance and scale. This is more in the back end, where we talk about the optimization, how to leverage certain techniques when it comes to the mathematical reformulation of the optimization problem. We can do metric scaling. We have done some experiments, and nowadays it's already in sort of a stage of being reused in LinoPy, where you have a persistent solver instance which you can reuse after you previously optimized your problem, and then Bender's problem decomposition. If all of this sounds too technical for you, that's totally fine. We're not talking about these features in the panel discussion. I just want to give you the impression of what the feature gap is and how do we want to address it. And this brings me to the next point. Our approach is, when we look at these different features and the gaps that we now identified, they're quite technical, right? And we want to bring them into PyPSA, into the PyPSA core, in a very stable manner. So it's a lot of things that we still want to change. It's an ongoing project. Compared to what was already done, it's not a lot, but it's been 10 years of development so far. So when implementing these new features and closing the gap, we want to really take care of backwards compatibility, consistency warnings, and fast patch releases whenever there's a bug occurring, which we hopefully don't cost too much, because we have and we try to enforce high test coverage. So really making the tool stable in itself. And the next point would be security. We want to do vulnerability scanning. We're already doing this. It's a critical thing for clients in the critical infrastructure, and we see a growing demand in that direction. We want to make the features more accessible to users. So thinking about a graphical user interface, abstraction layers, front-end functions that people and even sort of new programmers without proficient skills can leverage without knowing too much of the details that are going on in the background. CLI integration and transparent data model and documentation. And the last point would be performance. We want to scale energy system modeling very well. So whenever you do complex energy system modeling, you have to rely on the performance of the tools in order to make this thing work in a feasible time, and to process all the data, optimize all the data in a certain time that is suitable. You can get in touch with us. We have this is an openly launched initiative, and there is this philosophical view that people should be engaged, and you can engage yourself. You can tell us what you need. You can raise an issue on GitHub, either on PyPSA itself, or even through a message, an email, whenever you want. And perhaps there is some restrictions from your company that you have not access to, or sufficient access to GitHub. You can partner with us, sponsor a feature, fund development, or bring your own real-world models as test cases and as examples that we can examine. And of course, there's always this route to contribute directly to the GitHub repository. This project is fully open, the roadmap is fully open, and the code and feedback is always welcome. So that said, the initiative PyPSA-Taskforce is a collaborative initiative between Technical University Berlin, University of Pisa, and Open Energy Transition. And it has a roadmap openly available. We'll send the link around, which is embedded in the PyPSA roadmap itself. So it is sort of a subset of the features that we still want to ship outside of the gap analysis that I just explained here. It's embedded into this larger strategy. I guess if you've not already seen it, there's a roadmap page for PyPSA, which is very nicely for visualization. And this is sort of a subset of this, and we aligned with this roadmap in itself. And this brings me back to Bryn.
Thank you very much, Fabian. Before I open up the floor to the questions that are coming in from the audience in the Slido, please do continue adding them. I don't know if we've got the QR code we can easily show, or that people will find the link for it in this meeting chat as well. So please do keep adding your questions. Before we head over to those questions, I've got a couple of my own. This is the cheeky thing that you get to do as the chair of a meeting. The first would be to the three panel members, which of these features or feature themes that Fabian has just spoken about are your most anticipated features? And I would start off by asking that question to Patrick.
Yeah, thank you, Brian. I hope you can hear me. Perfect. One of the things Fabian spoke about, which here also from the TSO side is really interesting, will be the GUI he just talked about. This is one of the things we anticipate here a little, so it is also compared to some mainstream proprietary tools. They usually have a GUI. There's something missing here in PyPSA currently. So now you need some development experience, even if you're not a developer. And I think with the GUI, even people who have never seen some VS Code or PyCharm, whatever you need to run PyPSA, will be able to use it efficiently. And we're looking forward for the people who will use it in the studies internally or externally, whatever we will trying to do, or do some simple sensitivities. Yeah.
Great. Yeah. And Iegor, from the academic perspective, what are you most anticipating?
Thanks, Bryn, and hi, everyone. I think as for most anticipated features, for me, from academic perspective, it would be a close call between the two. The first one is developing further this functionality for optimization and uncertainty PyPSA features. So since version 1.0 PyPSA features stochastic optimization and all these methods to conveniently, quickly formulate stochastic problems, and later it was expanded that now you can also do risk-averse optimization, where modeler says this is my degree of risk aversion, and PyPSA helps you to formulate such optimization problems that will endogenously find what is the risky or what are more expensive scenarios and shift some weight of decisions towards this. The feature which is planned in the roadmap here is recurse investment decisions, which means a modeler will be able to conveniently map which investment decisions have to be done here and now and full stop, and which investment decision can be done now or can be postponed a bit for later. And it's very topical because now both research and business users use optimization for making decisions under uncertainty, but some decisions can be postponed, some cannot, and PyPSA will help you doing that. And the second feature is on endogenous learning, which will be added most likely this year. And when we do investment problems, we typically work with cost of capital. And we usually, all optimization models do not account for a feedback loop between how much technology has been invested and what is the specific cost of capital for this technology. Endogenous learning, put short, allows you to have this feedback loop. And this is very important both for modeling from system perspective, where you would like to have the feedback loop when we model large systems and we invest into advanced clean technologies like fervor energy for advanced geothermal or form energy for iron air battery storage. And we have a feedback loop that we invest more of this and we unlock some economical and environmental benefits of doing so. And it's also important for all of the work for so-called out-of-scope emission accounting for companies and institutions who do R&D grants or fund or invest into these technologies. And for that, you would need to understand the mapping between initial investment and how much catalyzed emission reduction you cause in the system. So for all of this, endogenous learning is a great feature. And yeah, these are two things I would call
I'm
myself.
looking forward to seeing those coming this year. They sound like great decision support tools, and I guess we're seeing two very different ends of the spectrum there of decision support around ease of access to what's already there, almost, to expanding out into much more advanced functionality in a particular decision-making domain. Fabian, does your most anticipated feature or features fit somewhere in that range, one end or the other?
I mean, I have a preference for all of these features. My personal take would be that I'm very much looking for the piecewise efficiency support in PyPSA, wherever you have a generator, or it can be any process, you name it, and you have an efficiency that is a function of the operational state itself. The same can be applied to the cost. So whenever you have a cost term that is as a function of the operational state of the asset. This is something that we've been working on during the last couple of months. It touches quite some bits of the whole process chaining in PyPSA, because on the back end, we are leveraging the LinearPy package, and there has to be done some quite data processing and new containers that we ramped up for this feature in particular, that we then leverage on the PyPSA side. So it goes through all this chain of communicating with the solver. There is another layer to this. We have a reformulation technique in LinearPy instantiated that can be used by PyPSA automatically now with this tool coming. So I love these features, and I'm a little bit biased here because I'm mostly working in this programming domain that touch a lot of fields in the packages. So whenever it comes to optimization, this also counts for the Benders decomposition and the persistent solver that we just tackled in the last week. A little bit to that topic, persistent solver is whenever you have a warm heated optimization that you just ran and you want to sort of reuse that solver state that you just optimized. And from the solution that you just calculated, you can then deviate a little bit by updating certain constraints or bounds of the variables. And then you let the solver recalculate and refine the optimum that takes into account these deviations that you just implied. And this helps tremendously when you think about rolling horizon optimizations in PyPSA, where you shift from one week to another and just a certain subset of constraints are actually modified. It could be renewable availability, and it could be unit commitment parameters. And these are then really fitting nicely into the already pre-solved solver model, and from there you get real performance benefit. So for me, it's really these features that touch optimization and data processing. I could name a couple of other things, but I guess I stop here.
Yeah, great. Again, you've gone down a completely different vector of it. A lot of the sort of hidden workings that make things more performant as well, which is pretty critical. And what you're highlighting here is the fact that the development's happening very rapidly at the moment. You're talking about changes that have happened in the last weeks or months. Igor's talking about developments that are going to happen coming up in the coming months. How and I'll throw this to Patrick first is, how would you like to see this as a transmission system operator, at the user level, balance sort of against stability of the tool and security of the tool and backwards compatibility?
Yeah, so from our perspective, we need to have this backwards compatibility. So as I just mentioned, we do lots of sensitivities also with our processes we have a mandate for, and sometimes to check some new connectors or a different setup of the overall system in Germany, Europe, whatever. And there, just to know that the model results are the same, that that's not an overachiever at the end, and so there's a new feature and it completely everything overboard we just have developed could be a problem from our perspective, since our processes usually come in some longer periods of 2 years, 3 years, and so on. So compatibility and stability is really good, is a good feature, but also, of course, like rapid development, and as we see here, that there's tremendous progress also made in the last 10 years when PyPSA was first developed as just a power system tool, and now, as we see, for example, PyPSA your sector with its really huge amount of features and ways how you can view the possible energy transition in Europe is great, but again, if we can't reproduce the results sufficiently, then the value gets a little low. That could be a problem. As long as reproducible and can be reproduced by a lot of people, then from other TSOs, not only for the German ones, so that they have the same results and we can argue on the same level. This is a big value for us here in the industry.
No, yeah, definitely. And I know in sort of the team in TU Berlin that there's a lot of talk about how do you retain this backwards compatibility and stability. I don't know, Igor, if you've got any comments on, how is this balance between speed of development and this maintaining compatibility being achieved?
Yes, I can just confirm and maybe reiterate the same what Patrick mentioned. I think for academia, but also more broadly for research, stability of the tool and backwards compatibility is as important as it's for business users. I think all people who in the audience did research or did a PhD, you might know it's very handy that you can come to, or it's very important that you can come to a code you wrote long time ago for a paper or research project, and now it's peer review, stage 1 after a year, and you come to the code and code yields exactly the same result as was before. If you are using open source modern stack, like for example PyPSA ecosystem or other open source tools, you can achieve this because you can pin the packages and you can use the same version of technology database that is part of ecosystem. And you have same results, but it's also very handy if you can update PyPSA and you benefit from all these features that are being added, but your for old codes and your old projects still yield the same results. And if something has changed, you see either a nice migration guide, or if something will change in the future, you have a deprecation warning for you, and that removes all the headache and technical overhead and just lets you focus on what's important is your research. So that's as important, I would say, for us as it is for business users.
Yeah, all of this maintenance overhead that nobody thinks about, taking time and effort to ensure that you can keep that level of quality. And a lot of that requires contributions from the wider community. It can't just be done by a core set of people. whether that's direct contributions or just highlighting issues that have come up, maybe that have slipped through the net. Fabian, you mentioned a few ways to sort of get involved. Do you have sort of ways that you would most hope that people are contributing to it, to the effort from the wider community?
Yes, there is definitely sort of the ideal picture that I would imagine. So we have the GitHub repository. It's openly available. Everybody who has a GitHub account can post issues there. And what we'd like to see is other people who either didn't come in touch with the PyPSA tool, they first have a look at the documentation and see what features are actually provided by the tool, and then read through the documentation, have a look and get a feeling for the program itself. And whenever you see a certain bug or you see a feature that you're missing, you can raise an issue or feature request on GitHub itself after you searched for existing features and existing issues that are on the repository. At the moment, we have quite some feature requests just coming also from this project alone. So there is a lot of complex things that go around, that float around. And whenever you want to have a look at them, it would be great whether your particular issue fits into one of these, and then you can ideally even link them. If you see that your issue is already there, you can give it either a thumbs up, or you just write a comment and a example of use case why you think this is really helpful and needed. And then we can sort of prioritize this more if we see there's a really strong demand for it. So I guess getting involved on the repository is the main take, and trying to make it, or help us to make it consistent, not bloating it either with AI or with just random comments, seeing what is there and trying to integrate that information.
Great. And just back to Patrick briefly on how are TSOs, or like how is your organization, or how are you seeing TSOs contributing at the moment to it? Because we sort of have generally a good understanding of how maybe it's being done in and around the academic setting, but how does it work when you are a TSO wanting to contribute, and how would you best see TSOs contributing to an initiative like the PyPSA-Taskforce and roadmap?
Currently, we are on the way of learning PyPSA and trying to integrate it into our processes and into the systems. But we definitely saw things as TSOs or as Amprion. We can do better. So where our own developments are superior to what's now is provided by TSO, and I say here from our space we should be open to the overall ecosystem, not from academia but also from industry side, especially in an open source ecosystem. I myself did still in a PhD program where we had our own open source energy system, and it was really great to profit from development of others, because then you don't have to do so much work, and if you give back, so it's not really good if you develop something great and it just sits in your closet or in your desk somewhere, and nobody uses it. So we could, for example, we have, as an example, we have, for example, a network reduction approach, which is like an optimization approach compared to what you have here in PyPSA with your clustering. So we analyzed things like this. One of our colleagues did a nice paper on this, and I would say, and go to other TSOs and other energy supply. So don't be too overprotective with your own developments, and push it that anybody can use it, because it's a task of taking and giving, and if you give more, other people can profit from it, and you can profit even more the more people are willing to publish open source. And maybe there's an opportunity maybe something here which the community can do, something that still can be claimed intellectual property for this. So maybe there's something that best feature of the month with something with whoever published it and something like this. So I think this is something with a little reward system which would help a lot to push this community.
Yeah, no, we are very open and about celebrating, I think, a lot of the contributions we get across the entire open source ecosystem and PyPSA in particular as well. So if you do contribute, we will celebrate you. I'd like to ask Charlotte, could you possibly share the Slido with the questions coming in from the audience so we can move on to some of those? Because I've been reading a few of these, and one of them that comes up towards the top is, and I'll just highlight it here, is this question of validation studies against commercial tools, and I'll start off with Fabian. You've not had much to say recently, and then I'll come on to you, Patrick, because I'm imagining that you have done internal validation studies as well. But Fabian, from your perspective, working on projects, what has been the experience with validation against commercial tools, if you have done it?
I have not done it because there was always this restriction that I don't have access to commercial tools. I guess what we have done is validation of our models against real world. So there is historical data on energy system environment. So you can always cross-check whether your model that you just optimize makes sense against these sort of historical reports. But it is not, in a strict sense, a validation against the commercial tools, right? The only thing that we can do is running the constraints and the optimization or whatever functionality we have and see whether the mathematical interpretation makes sense. I would be curious if another one in this round did something like that. So from my perspective, it's nothing that I personally did.
So then I guess Patrick has disappeared into the void. Probably needing to charge his headphones by the looks of it. So I guess the question, if you're still with us, Patrick, is whether you internally, like within Amprion, part of the work you've done when you've looked at using PyPSA has involved validating against commercial tools that you may have already been using internally. I think we might have lost your voice. I know you're back.
Can you hear me again?
Yes, we can.
Yeah, perfect. So we didn't do direct validations. So we have some processes involved, and we built some test models. So we have, for example, our internal developments, and we did some really easy 3-bus calculations against these results. We have there, for example, some test methods for flow, physical flows, and for dispatch modeling. But it wasn't currently this deep, because we are still in the process of looking into the system and finding out which features are necessary that we can, for example, tackle some of the processes we needed to needed to do as a TSO.
Yeah, so a lot of the validation isn't necessarily like for like. It's more about saying, can it do on a feature perspective the right kinds of things, and not necessarily saying, can it produce exactly the same numbers as another tool. And as you say, Fabian, we've always got the constraint that we can't necessarily ever run those commercial tools that produce a certain set of results to do a perfect validation. Another question I saw popping up there a moment ago was about capacity building, and I'll see if I can find it whilst I think about saying it, is thinking about sort of resources to learn and to develop further in using PyPSA. Where would you be aiming to point people to? Where do you think maybe there is a lack at the moment in sort of the PyPSA community at the moment more generally in terms of learning material? And where do you think there is people can go to first, or where should they be going to first for their initiation and into PyPSA, and then going further into the details? And I'd ask that of Iegor first, I think, because I think there's been some work at TU Berlin that's in this domain.
Yeah, thanks, Bryn. I think there is plenty of resources, and I don't know which one to choose first. But one thing is that it's fair to say that PyPSA documentation, it's now really good. It's very extensive. It's very detailed. We have a big collection of examples of PyPSA being used to solve specific optimization problem in the real world, and there is a chatbot that actually works and it helps. And I use sometimes chatbot myself if I'm lazy to open source code and search for it. So that's first thing. Second thing, there is fantastic course by Fabian Hofmann, my colleague. It's called Data Science for Energy System Modeling, which has been taught in TU Berlin. But if you are not a Berlin student, or if it's already late to be a student, the course is fully online. It's the one website. All notebooks are available. You can go along and solve notebooks. You can download and solve it on your ID, or you can just solve it directly on the website. There is videos for all classes, and it fully covers PyPSA ecosystem, LinoPy, solving investment problems. I think it's a great resource. We also run a series of workshops for industry, TSOs, and academia last year, and we have sort of dedicated web pages for all of these workshops with all the materials available. You can visit them, and we sort of plan to do workshops as well for the end of this year. You are welcome to register. I think OIT is also doing great workshops for TSOs, so some series of dedicated meetings where TSOs can ask questions, and maybe bounce to you, Fabian, to tell me more about that.
Yeah, perhaps I can just quickly compliment. I guess the resources that Iegor described, they are the go-to for beginners and even advanced users. There's a lot of things you can learn from these, and how to do more complex stuff with PyPSA. It's all there. We have, of course, also activities around training people and bringing this competence into companies. It's something that we provide, but it is not our field of expertise, I'd say, in the first place. But it is our mission to sort of provide this knowledge and spread this knowledge around PyPSA. We have a PyPSA training session given that was partially also led by me. It's also fully online on the OT website. You can find it. I can also post a link later, where I personally made a session on the statistics module and how to derive nice plots from the statistics module from a quite complex PyPSA network. So this will help you to inspect results and analyze the outcome of the optimization. But it's just a tiny bit of the functionality that is already covered also by the other courses that Iegor mentioned.
Great. And of these that have been mentioned by Iegor and Fabian, which, if any, have you taken advantage of, Patrick? And have you even developed things internally or pushed things internally for capacity building?
Yeah, we first of all, we had a workshop with Fabian and also, I think Max Parzan, who visited us at Amprion, and were really helpful. First of all, that we are getting to know PyPSA, that we got to know the ecosystem and what's the plan, what is the plan for this. And when I started with PyPSA, so again, I have already had an energy systems background, but the first thing I did, I went through the documentation, which is superior to anything I've ever seen in open source. from there on, it was really easy to learn the different objects and the different modeling tools, how you use it, how you fill your network, and so on. Also, for example, if there was something which was not included, the LinoPy documentation. So if you get a little further and want to implement your own constraints, was again really helpful. And I also wanted to say what Iegor said. So even the Google AI chatbot really is also really helpful when it comes to programming or introducing new PyPSA variables or new PyPSA models. And on an easy level, usually you say, again, 3-bus system, and I want to try this, and it really gives you a good code. You just have to take care that it knows what kind of LinoPy and PyPSA version you use, and then it gives us a really usable code for your first tries. And yeah, that was really good. And usually learning by doing and doing mistakes over and over again helps a lot to learn the system to the end.
No, definitely. I've got this sort of pinged to the top, this question of sponsoring a feature. So if we're talking about all of these various features, they go from the deep internals around efficiency improvements to technical features through to what the user sees on the front end. How on earth would one go around sponsoring it or develop? How do we get development funded? I might throw that to Fabian to sort of maybe talk about it from the PyPSA-Taskforce perspective.
I guess what you can do is, first of all, probably approach me, because for this task force, I'm in the lead and coordinating things, and then we find a way to allocate this. It is a thing that we are definitely open to. And there is the roadmap, there is the items that you see there, and this is our current plan. But if you have anything that you want to see beyond that, and where you see, okay, this is something that we really want to have implemented within PyPSA, within the PyPSA core, in order to be fully integrated with the tool, this is definitely something that we can talk about. And I guess the first thing would be contacting me. It could also be contacting Bryn or one of the other members of the task force, and we'd definitely get in conversation there.
Great. Back to the features themselves. There was some talk about this Google AI support, and there's a couple of questions. I'm going to chuck one of them up about AI usage. What do you see sort of as the role for AI and machine learning in the sort of work of PyPSA? Can you sort of comment on maybe how you've used it, or how you might imagine seeing that becoming a core feature of the PyPSA tool? I'll throw that to Iegor first.
Oh, thanks, Bryn, for throwing the most difficult question to Iegor first. Yes, I must admit I have my opinion, but I'm not sure I'm the best person to answer. Maybe Fabian or even you would be better to give an overarching answer. My impression, AI helps a lot. If you think about PyPSA development, we obviously challenge our code whenever we write a new feature, or we do bug testing with AI, and we make sure that our code holds for all the edge cases. And AI is very helpful to evaluate all of these edge cases and potential pitfalls, so you can think as smart reviewer. Usually my philosophy is to try to use as little AI possible for core code of optimization, because there's stability and hallucination, and you want a real person with real sense of responsibility and feeling of right and wrong do optimization code. But definitely all of us use quite a lot of AI for speeding up development of features, and certainly for prototyping unit tests and things like that. Fabian, you possibly have also quite a lot to say.
Yeah, I guess we make all our personal adventures with these tools. They are super powerful, and they sort of lead you sometimes into the trap of something appearing to be functional where it's not, or it's not well integrated into the tool at all. Therefore, I guess it's a learning for all of us, even for us developers, which are in the field for more than a couple of years. What I see personally as a real strength of the tools is in terms of planning and prototyping and debugging. So what we currently do a lot in LinoPy is trying to find good ways in order to implement certain features that drive well with the existing tool set. And we're doing a lot of iterations with the LLMs on planning. And whenever we have a plan, we post that and send that over to a colleague, or post that in the GitHub repository, while claiming that this plan was AI written or assisted. This needs to be this is a convention in our repositories, that whenever you write something with AI, it has to be clear to the community that this was not you who wrote it. And I guess when you sort of abstract that away and you really see it as a tool for planning and debugging, it really can help you well. And I guess
I would jump in and sort of ask,
yeah, sure.
how would you see it from the modeler perspective using AI? How would you, because I think there was some brief mention there by Patrick about using a chatbot to support you actually maybe building a model to begin with, or maybe defining a custom constraint. Do you think this is a sort of a recommended approach already? Like, do we have methods for people to be able to do that effectively? Or would you say it's similar to sort of the underlying code that you would put a big warning flag against it, but only imagine it being used for modeling in very specific circumstances?
I'd rather say the latter. So really flag that this was AI written, and then it's clear to others what the context is, what we're talking about, what product are we seeing here. And the problem is even with the current nice, like the really powerful models, they often are trained with old code, and they might rely on old conventions in the code and not leverage sort of state-of-the-art new implementations that users might be aware of. So you can definitely write a PyPSA model with Claude or with Gemini. It's no problem at all, and it will be probably consistent in its data model. I wouldn't, for beginners, I wouldn't recommend, because it takes away this feeling that you get when producing such things, so the code yourself. When you just want to have a very tiny sort of prototype what you can play around with, you can do the first draft with the LLM and then play around again. I guess there's various things that you can do, but be aware that what the context is.
No, yeah, maybe definitely. A common warning that you should have. I'm not going to come to you on it, Patrick, although I think you've probably also got a lot of things to talk about, because I do want to ask one more question that covers a couple of the different points that have come up in here, and that's how PyPSA can or should interact with other tools. So there's a question here about system dynamics modeling. There was a question also about connecting to data formats that might be suitable for proprietary tools, even, so like PSSE. And I know that both Patrick and I we have been involved in development teams for completely different energy system modeling tools. And how would you see all of this feature development going towards better integration with these other tools, or perhaps just relying on these other tools for some of the features and things like that? So I might come first to Patrick and ask, what would you like to be able to see in terms of PyPSA interacting with other tools, upstream, downstream, and things like that?
Yeah, I think some interesting part would be, for example, is again, we both come from energy systems modeling, maybe to integrate this tools together, maybe in one tool at one point, so that, for example, everybody in Germany, depending on what university you are, or independently of which university you are, maybe use PyPSA, or however you want to name it then, as a as a reference tool, so that you don't have so much parallel development at the end and put so much resources into the same thing. And when it comes to other like economic tools or some dynamic model simulation tools for forecasting and so on, I think some very good interfaces will be necessary, which can also be a part of this community effort, that this can be integrated somehow. I think this comes together on these different interfaces in model building, scenario building, to have a consistent view on the closed or the closed system you want to analyze. And again, there are a lot of features which come into one of those scenarios, and there's a lot of things PyPSA can do now, but a lot of things PyPSA can't do because it's a different system and a different approach. And with really dedicated and good developed interfaces, you can all profit from all of it. For example, you can use a result from PyPSA and put them into an input-output economics model, and, for example, observe how the development of the electricity grid or the development of the renewable energies affect the employment rate in Europe and Germany and so on. So these are features, these are just inputs into another system, and to have interfaces like this and like a big model family, which this can be bring together everything. That is one would be one fantastic task.
No, yeah, definitely, and I think I/O generally, so input output is on the roadmap. Improving that, shoring that up, and making it ultimately easier and more feasible to connect to various other tools. We've only got a couple of minutes left, so I'm going to ask in the time remaining for some just parting thoughts from each of the panelists. So when it comes to this effort, the task force, and to PyPSA development more generally, some parting thoughts from you. And I would start off with Iegor.
Yes, I think as a closing thought, just maybe a message for all the users of PyPSA, whether it's from academia, research, industry, or what else. You are very much encouraged to ship us a feature ideas and just using issues. If there is certain features which are of broad value and interest, and they are not for some reason on our roadmap, they definitely will be on the roadmap. And second thing, you are very welcome to always indicate some inconsistencies of bugs. It's not to say that PyPSA ecosystem is prone to bugs. All software have this, but with open ecosystem, you definitely have benefit of seeing transparently how we immediately react to bugs and fix them, and you see what exactly been changed. So everyone is welcome doing that. Great,
thank you. And to Patrick.
Yeah, I would also encourage everyone to participate in this system. I already said it. Don't be too overprotective with your own developments. I think you can make a great deal by joining and participating. And maybe you see something we all have overlooked, and then it would be great to just improve the modeling for everyone and see what comes out of it. So, for example, we're here at Amprion. We are open to this, and we are currently proving if all this is possible, and definitely could see ourselves at the future pushing some of our features, which will be then have our private branch to the main system. And I can also only encourage you, look in the PyPSA primary main branch and look what great things there are in the pipeline and will be developed, and you can be part of this.
Definitely. And then finally from Fabian.
Yes, I would probably mostly repeat. So contribute, shout out when you have things that you want to share. There is often the situation where we also find ourselves as developers in this sort of middle ground where we could either go for one option or the other. And then the feedback from the community is also very, very welcome, because we don't know where the sort of the users stand on this particular question. So even when an issue seems to be sort of clear in its sense and the definition is there, shout out when you have an opinion, an opposite opinion on this. And when you see there's live discussions around that, then take one side that you prefer, and then we can incorporate that and prioritize that.
Great. Well, thank you all for your very aligned messaging. This was not pre-planned on really being part of the community. Join the community, whether you are in a academic setting, whether you're just a private individual, whether you're in a industry setting. Do get involved in any form that you feel comfortable getting involved in, and that can just be voicing your opinion on something. It can be direct involvement as well. Do also just keep an eye on where we're going and the roadmap that PyPSA currently has, because we are actively tackling some of these key core elements on that roadmap with the task force. And if you are a really dedicated individual with a lot of resource and time on your hands, then you can directly join the task force as well. We would be happy to have you. There are various other questions that were on the Slido that we didn't get around to discussing, and I'm sorry to those who didn't get anything answered. But if you do want to get that question answered, then do just reach out to us directly by email, on Discord, or on the GitHub channel, and we will be happy to respond. Other than that, thank you all for joining, and have a good evening.